Okay, here we go. This will be the parent every time. Y equals b to the x. So guys, when you look at this problem right here, let's bring it over here. I'll write it bigger for you. Y equals what? Negative 0.5 times 5 to the x. What's the parent? Nobody can tell me? Guys, here's what I'm trying to tell you. Pick up the base, raise it to the x. That's the parent. What's the parent? We're really stuck here. This is the base to the x. That's the parent. Which one's the base? 5 to the what? X. That's the parent. Okay, that's all I wanted you to tell me. The parent is always going to be the base number to the x power. So, write that down. And then, of course, I'm going to ask you to graph it. But then once you graph the parent, then just do whatever you have to do. Somebody tell me what this number means right here. What's the point? What's the 0.5 in front of it? Not this second. Okay. You want to get them working? I'll sign it. Okay. Hey guys, what's the 0.5 mean?
Half.
Yeah. Translations. What?
Compress.
Stretch, compress. Which one?
Compress.
It's less than 1. It's a compression of what? Compress
Half.
by a half. Which basically means make the y value half as big. What's this little thing mean right here, this negative? Yeah, that's a reflection over what? Reflect over x axis. Got it. Got it. Okay, so this is what we're going to do. We're going to graph the parent, then we're going to compress it by a half, and then we're going to reflect it. Okay? All right. Now, I'm going to go quick. I hope you can go quick with me. To get the parent, put down a table. Good numbers to try are what?
-2.
Okay, I heard saying 1, 2, 0. Yep, that's good. You don't have to go -3. You don't have to go +3. Okay, if you throw some easy numbers in like 0, 5 to the 0, 1, 5 to the first, 5 to the second. Now, hey, you guys are so quick at this, you don't have to sit there and take all that time punching your calculator. You should know these 3 answers right off the bat. On the back side, negatives get a little tougher, but really, there's a pattern. What's 5 to the -1? 1 over 5 to the first. 1 what? 5th, right? What's 5 to the -2? 1 over 5 squared, which is 1/25th.
Don't you have to multiply them by your...
I'm not going to do that yet. I'll do that once I graph the parent. Hey guys, look. See this? This is the parent. This is not the answer. But, I was going to tell you this. Do you notice a pattern? Square it, 25. Take it to the -2nd, 1 over 25, right? This pattern is always there. 5 to the first, 5. 5 to the -1st, 1 over 5. This is why I'm saying this shouldn't take you very long. If this is my biggest number, 25, I should probably go by 5s? Okay, so I'll go by 5. Here we go. 2 gets 25. 1 gets 5. Okay, I'm just throwing some numbers in so you can see it better. 0 gets 1. And -1 and -2 get really tiny numbers like 1/5, 1/25. So you're going to just be a little bit above the x-axis. See the growth? Remember what it does on the backside. It just does what? No idea? It rides the x-axis, doesn't it? There it goes. Okay. So that's the parent, correct? Now what are we going to do to the parent? That 0.5 says do what? Compress it by a half, which means take the y value and shrink it by a half. Yeah, Brady.
Is there something like the basketball that does this, but it's not decaying?
The basketball?
Yeah,
Not sure what you're saying.
like you know how the basketball splits in height.
No. I mean, no. We're not going to go into the basketball problem. You know, first of all, basketball problem, that basketball problem is decay. This is growth, right?
I was just wondering if there was something I could compare this to.
Money grows. As money grows, as population grows. I wouldn't think of a basketball bouncing on this one. Here, help me out, guys. 0.5. 0.5 is going to be, you're up 25. Where are you at now?
12.5.
12.5 is about here. Okay, what's this negative do? Reflects it over the x-axis. So if you're up 12.5, now where are you at? You're down 12.5, about here. So this point up here is now down here. 12.5 down. Okay, let's do it again. This point is 5 up. What's half of 5? 2.5. And then reflect 2.5 over the x-axis, you're down to negative 2.5. So more or less, this thing is just shrinking by a half and getting reflected over the x-axis. Okay, let's do this one. This is the number 1. You're up 1. What's half of 1? Half. Now reflect a half. Negative a half. So far, guys, this is what I see. I see this look. Okay. Now, the other points are very difficult to do because they're such small y values. If you took this y value right here, which is, I believe, 1/5, isn't it? If you take 1/5 and you cut it in half, you're down to 1/10. Now 1/10 gets reflected over the x-axis. Guess what? You're right there. You're right there. You're right there. So everything gets reflected over the x-axis because when you take half the height, you're still right on the x-axis. So when you reflect, you're up just over the other side. So here it is. This red graph would be negative 0.5 times what? 5 to the x. Good? If I were to correct this on the test, I would do this. I would concentrate on that point. Why that point? Because that point changed the most, didn't it? 25 up, half of that, 12.5, flip it, negative 12.5. If you got that on the test, I'd go, you get it. You totally get it. And then, of course, I'm going to look, where did they flatten out? Right under the x-axis. Okay? I need this. I need this. Domain range. What's the domain? I heard you say this. All reals. Is that true? Hey, would 5 get an answer? Look down. Look down there. Yeah, eventually it will because this graph keeps moving left even though it's going straight down. It's still moving left. Okay, what about the range? All y's what? Hey, look. 5 came out, 4 came out, 2 came out. Everything what? Louder, Jesse. Besides 0. Did the positives come out? No. Everything came out that was less than 0. All y values coming out are less than 0. 0 doesn't come out and the positives don't come out. So yesterday I talked about this, but I always said yesterday, y is greater than 0. Well, today, if I reflect it, everything's less than 0. You okay with that? Okay. Hey, this transformation stuff is weird stuff, right? You got to be careful with this. All right. Next, let's do this one. Would you please tell me the parent? Just look at the parent. Pick out the base. What's the base? 4. And whatever the base is, just raise it to the x. This is the parent, and this is what's going on right here. This is what's happening to the parent. And when you wrap the x in parentheses and you go x plus 2, which way do I go? Yeah, that's a right or left movement, and we said it's the opposite of what you think. Plus 2, seems like it's this way, it's left. So this is going to go left 2. Would you please graph that and then move it left 2? I'll catch up with you. Hang on. Jaden, Kristen, hang on. You're not going to take the quiz. Unless you want to come in tonight, take it. Okay. All right. You're probably way ahead of me now. A quick table on this would be, here we go. 0 goes in, 1 goes in, 2 goes in. 4 squared. 16. 4 to the first. 4. 4 to the 0. 4 to the negative 1. 4 to the negative 2. Okay. Look at the pattern. You get 16 on the top and you get 1/16 on the bottom. This always will hold true. Okay? Now, if I graph it, I see 16 is my biggest number. Maybe I'll go by 2s. Okay, I'll go by 2s. So here is 8, 10. Ouch, this isn't going to be easy.
4s.
Go by 4s.
Yeah,
Go by 4s. Wait a minute, 6 would be 12. No, this should work. I messed that up. Sorry.
4s would be easier because you have to graph them.
Yeah. Do you really think so?
Yeah.
Because I gotta go left to, yeah, I suppose I could do it. Okay, so 4, 8, 12, 16. Okay. So a quick graph would be 0, 1. 1, 4. 2, 16. And then from here it just rides the x-axis, doesn't it? Okay, right? Okay, I'm going by 4s is what I'm doing, going by 4s. Okay, well, you know that's the parent. What are we going to do with the parent? Left, left, 2, go left 2. So let me change my color. If I go left 2, it's going to be not 2/16, 0/16. 1, 4, no, it's going to be negative 1, 4. This point moves right about here. This point moves here. This point moves here. So guys, it almost looks like the same graph as soon as you get to the x-axis, right? I mean, it's on the x-axis, when you go left and you go right, it looks the same. It does. You okay with that? So which point am I staring at on your test? Which point? Right here. I'm looking for that one. I'm looking for this one. And then after that, guys, as long as you stay above the x-axis, I really don't care because I know you can't show me a difference anyways. Those 2 points are huge, okay? All right. Questions? Okay, all right, no questions. We'll move on. This one. I'm going to rewrite this so I see it better. Okay, here it is. Okay, you have to be so careful about how you do this. First of all, somebody tell me the parent. What's the parent? 2 to the x. Okay. A quick table. Negative 2, negative 1, 0, 1, 2. Fill it in, and then we'll talk about the moves. Okay? We'll talk about the moves. How are you doing? Everybody okay? Get the parent graph, and then we'll do the transformations. Do a table. Hey, Bryce, help me out. 2 to the 0.
One.
Thank you. 2 to the first.
Two.
2 to the second.
4.
And if you've ever noticed these patterns, the other side will be 1 over
2.
and 1 over.
4.
Yeah. I mean, really, that table could be done in 10 seconds. That's how quick you can do it. I'm going by ones on this one. 0, 1, 1, 2, 2, 4, 1 half, and 1 fourth. Here it is right there. Now if I continue, it goes like this. If I continue, it rides the x-axis. Parents on paper. Now my question to you is this. What's the first thing that happens to the parent when you look at all this garbage?
-1.
X minus 1. Okay. Now you don't see grouping symbols. But they're there. Because if you put a number in for x, like 5, what's the first thing you would do? 5 minus 1. See, they are there. They're telling you to do what's inside. So what does this mean? Write 1. So here's the first thing you do. Write 1. The second thing you do is the multiplier. What's this mean? Is that a stretch or is that a compression? Okay, stretch. So take every y value and do what to it? Multiply it by 3. That's all you got to do. What's next is this. What's this mean? Reflect over what?
X.
X-axis. Okay. Next. Last but not least, this one. That's an up 3. That's all you got to do. Sorry, that's a lot. But you have to do all 4 things. Here we go. Let's go black. Okay, here we go. Let's go right 1. Pick a point. I usually pick this point right here. Right 1. Here I am right there. Now, I'm up. My y value, I'm up 1. Multiply your y value by 3. 1 times 3. 3, I'll be up. Now I'm going to triple my height. I'll be up here at 3. Now what am I going to do to 3? Reflect it. So if 3 up, now I'm 3 down, right? But wait a minute. I got to go what? Up 3. So we'll go up 3. Right. Oh, look at that. Where did you end up? Your 0, 1 ends up at 1, 0. That's where you're at. Keep going. Do it again. Pick this point. Write 1. Put you here. What are you going to do to that y value? That y value is 2, by the way. What are you going to do to it?
Times 3.
Yeah, triple it. What's 2 times 3?
6.
6. You're up to what? You're up here at 6. Now what are you going to do to 6? Reflect it over the x-axis. 6 goes where? Down to -6, right here. Then what do you do? Up 3 from there. 1, 2, 3. Here I am. Now I got a bunch of dots everywhere. Hang on, let me get rid of a few of these. These are not here. Okay, all right, now continue. Go to this point right here. Move it right 1. Did it. Here's where I'm at. Triple that height, guys. If you triple 4, you get what?
Get 12.
12. Okay, so now you're way up here at 12. Okay, where are you going to go? Reflect it to what? -12. Then you got to go up 3 from -12. Where are you going to end up at?
-9.
-9. Thank you. So you're going to end up 1, 2, 3, about here. So what you get is 3, comma, -9. Here's your graph so far. So far, it looks like that. Here's where things get tough because now your y value is a fraction. Move it right 1. Right 1 would be here. You're at a half. Triple a half.
1.5.
1.5 is here. Reflect it. 1.5. Down 1.5. Now go up 3. 1, 2, Oh, look, I'm right there. 3. There it is. So far, it's looking like that. Last one. Here we go. This point right here. Move it right 1. How high up am I? Right there? I'm up a 4th. Triple a 4th. Triple a 4th, you get what? 4th, 4th, 4th. 3/4. You're at 3/4 right here. Then you're at negative 3/4 right here. And then up 3 units. 1, 2, 3. Here's where you're at. Okay. Now that's it. You're done. Problem is, I can't see what you're writing above or below. Can you? Should I just go like this? Is that going to work? No, because guys, you wrote it out on the x-axis. Something's wrong here. Here's what I would do if I were you. I'd go like this. I would pick a point like over here and just talk to yourself. Okay, what's this point going to do? Right 1. Okay, triple the height. Oh, by the way, you're almost on 0. Triple 0, what do you get? 0, a little above 0. Flip it. Now you're a little below 0. Now go up 3. 1, 2, 3. You're right here. So this is what it does. It goes like that. Now, can I ask you this? How do you know what the line that you write underneath or above? How are you ever going to know what it is? Okay, look, watch. See this? See this? This is the parent growth. What does the parent do all the time? Rides out on what? The x-axis. What's the only thing that's going to change this? Up or down? Up or down? What moved up? We moved up what? 3 units. So basically, guys, the asymptote moves up 3 units. It's really just this number right here. This number determines where your function rides out on. Why are we below 3, by the way? Why did we fall below 3? Because of what? What did this do? You reflected it. You were going to be above 3. Well, you got reflected. You're below 3. Hopefully that makes some sense. What's the domain? All reals. That never changes. Okay, what's the range? All y values. Less than? Yeah. You never touched the line, did you? You never touched 3. All y values less than 3. If there's anything you might get wrong on the test, it's the range. The range is the hard one. The domain is the easy one. What's the answer for the domain every time? All real numbers. Say it. Just all real numbers. Every time. You messed that up, you didn't listen to class. This is what you'll get wrong right here. Because you don't quite understand what it's writing out below or above. Okay, that was a very tough problem. Yes, me. We're done graphing. Do not forget to pick up your graph paper when you leave. Okay, hey guys, this is a quick summary of what you and I just talked about, this table. All I want to tell you about stretches and compressions is basically this. All you have to do is multiply the y value by what number? Look here, look here. What number are you going to multiply by? A, the stretch factor, A. Bingo. That's it. Hey, the rest of this is just your horizontal movement, your vertical movement, stuff we've talked about over and over. Okay? All right. So that's just a quick summary of what you did. All right. Now we're shifting gears. Now we're going to go more into exponential growth and decay. This is just a quick story problem. And they give you a formula and they expect you to come up with an answer. All right. The initial temperature of a cup of coffee is what? 203 degrees Fahrenheit. You gonna take a big gulp of that or what? What's boiling?
212.
212 is boiling. That's 203. You better just barely touch that coffee. That's hot. Okay, listen to the rest of it because there's a formula that tells you how fast it cools up. An exponential model for temperature, Y. So what's Y stand for? Temperature of the coffee after X minutes. So X is minutes and Y is the temperature. As the minutes go on and on and on, the coffee temperature goes down, down, down. Okay, here's the formula. Y equals 134.5 times 956 to the X plus 68. Okay. How long does it take for your coffee to reach a temperature of 100 degrees? Where's this go? Temperature 100. Where's it go?
Why?
Okay, why? Okay. So here's your problem, guys. Go get me an answer. How many minutes does it take for the coffee to chill down to 100 degrees? How are you going to do it? What? Okay.
Is James not in this room?
Yeah, she is.
Can you please send her to the office for a few minutes?
Think she just going?
Thank you.
Yep, she's coming. Did you go talk to Kristen?
Yeah.
Okay. Okay, Jessica yells out, subtract 68. She's right. 32 equals 134.5 times this. So what she did is she's just trying to make it a little more simple. Is there anything else I can do to make it more simple?
Divide 134.
Yeah, get rid of your multiplier. Okay, that's out. 134.5 equals your base number to the x power. Help. 32 divided by 134.5. 0.2 what? Okay, you're just rounded in there as hundredth. Okay. Last period they went to the nearest thousandth. You're going. Jessica went to nearest hundredth. Well, hey, it's okay. It's okay. All I care about is this. Can you tell me? Can you tell me how many what? What does X stand for? How many minutes? How many minutes does it take for that coffee to get down to 100 degrees? This is where you guys have no way of doing this. I will teach you how to do this at the end of chapter 7. So now you have to pretty much do what?
Yes.
Guess it, check it, try again. Hey guys, if it's 203 degrees and it's going to cool down to 100, give me a guess.
20.
You think 1 minute? You think 2 minutes?
35.
35. Okay, well, okay, we got guesses now. Try it. Tell me when you get to 0.24. You see, some people are plugging away and some are just waiting for others to do their work. Come on, guys, work with me. If you got something close, let the class know.
30 is close. I don't know.
32 and 31.
32 and 31, Noah? Noah, at 31 minutes, what's the answer?
31.
31 minutes, what's the temperature of the coffee? Or sorry, what did you get? Did you get this?
0.247.
247, okay. At 32 minutes, what did you get?
0.236.
Point what?
236.
236. Which one's closer? Yeah, you know what? If I put a 0 there, guys, that's 240. Which one's closer? 32 is closer. But actually, 32 is a little short, isn't it? Okay, this one's over. This one's under. Can we up our minutes? Up the minutes. Let's go 32.2 minutes. Try that. Raise it to the 32.2.
I found a closer prediction.
What are you getting?
I got 31.7. That's
Oh, you're going the opposite way?
yeah. And I
31.7.
got,
What'd you get?
24.01.
0.2401.
Yeah.
Which is 0.240 anyway. Yeah, you got it. That's a good one. How many minutes? How many minutes? 31.7 minutes. Just about 32 minutes. Last hour we settled on 32. Last hour we said 32 minutes, good enough. You guys went really close. You went to 31.7. Okay. All right. I don't know when the bell's gonna ring. 30? Okay, 30 it is. Here's the deal. Are you sure it's 30?
Yes.
Okay. All right. Here, I gotta just tell you this. Would you please do this? Find this button on your calculator. It probably looks like this. Hit it, and then hit e to the first. Would you just hit that and tell me what e to the first is, and to the nearest 3 decimal places? 7.1 what? 8. Okay, guys, this is base E. Base E is like kind of like pi. Pi is 3.14. Base E is 2.718. This letter, this symbol, is used in many different formulas. One of the formulas is compound interest, and more or less you will always use it when you hear this word right here. When things compound, continuously, my fault. When you hear continuously, they're talking base E. Here's the formula they're going with, right there. Let me just tell you this. A lot of people just say this formula. They say the PERT formula. PERT, P times E, raise it to the what power? RT. Use this formula when you hear continuous growth. Now, let's do this one quick. I understand you're going to leave me a little bit, but here's what happened. You took $3,000. And because it's continuously compounding interest, you're going to use this PERT formula. So it's 3,000 times E, raise it to the 5%. For this problem, it's 8 years. It's 4 years in high school and 4 years in college. You leave your money there, and then you say, how much is my money worth? I really, really want you to plug this into your calculator. What is the value of your account after 8 years? If anything, before you walk out of this door, please punch this in. Find that button on your calculator. It looks like this. E to the X, or it just might simply be E on your calculator. Your $3,000 turns into what after 8 years? You guys.
Negative 2,000.
This is it. 4,400 something.
You typed her in.
Huh?
44.75.
75. Thank you. There it is. If you can't get that, come back to me. Talk to me.
So we're probably gonna have class tomorrow.
I think you will.
Okay.
I think you will.
I'm gonna actually look it up.
Yep.
I don't think I have it.
Yeah, if you have a scientific calculator, you probably have it.